Okay, well, good afternoon. So today I'm going to talk about assessing firesheds for prioritization, planning, and investment. And I'm going to try and stay out of the weeds in this talk. It's work that's been developing for a number of years. John Phipps, Deputy Chief State and Private, has been a champion of this work and stimulated a lot of our thinking, and I want to give him credit for that. Excuse me, collaborators. We just had a, excuse me, 7-day smoke event, which we're all suffering from, but Cody Evers, Portland State University, Michelle Day, Rocky Mountain Research Station, Rachel Hauptman from Oregon State University, Chris Ringo, also from OSU, and for me, Nalcosina, Mike Scanlon, Forest Service CIO, Tanya Ellersick, Washington office, and Pedro Bellavenuti also from Oregon State University. So it's a little bit of sort of science background on, I mean, today we're going to talk about wildfire disasters to developed areas and trying to predict them. And predicting wildfire disasters is a common goal for a diverse set of actors: land managers, homeowners, conservation biologists, physical scientists, and especially the insurance industry. So there are a lot of different players and a lot of different angles that people come at this problem from. And arguably, there's a lot of work to be done to improve our current risk analytics. I think the last couple of weeks aptly demonstrated that. There are many interacting drivers of wildfire loss to developed areas. There's a very rich, huge literature on this. People point to the expanding urban footprint, egress and evacuation problems, the increasing frequency of human ignitions, droughts, overwhelmed fire suppression capacity, changing climate, which I listed separately from droughts for different reasons, and extreme weather events, highly fragmented ownerships and risk governance systems, how we try and manage risk, and variable risk perception and willingness to treat fuels and home hardening activities, which some of these issues have been tackled by climate scientists, some by physical scientists, some by structural firefighting scientists, and some by social scientists, et cetera, and landscape planners, et cetera, et cetera. So it's a diverse literature that can be split to those that study empirical wildfire events versus use simulation. And has been a dichotomy in the literature. The empirical methods examine fire events with statistical models to understand how local factors such as fire intensity, fuels in the home ignition zone, and WUI configuration contribute to structural vulnerability and loss. Excuse me. The empirical methods, the sample sizes are limited to areas that have burned. They need a fire as a sample. But they're very valuable studies and provide course predictive power to non-burned areas, understanding what happened in burned areas, extrapolating that over to non-burned areas, because that's what we're interested in. But they do not generally have the capacity to investigate how fire spread from wildlands to communities. Wildfire event simulation, which Mark Finney has been responsible for quite a bit of the development of that science in the US. There are major fire simulation systems in other countries as well. Fire event simulation generates fine-scale maps of likelihood and intensity used by federal and state land management agencies and the insurance industry to estimate expected loss or financial risk. In the case of the insurance industry, estimating structure loss requires the use of structure vulnerability models. So these analyses focus on areas that have not recently burned versus the empirical studies. Simulation modeling can be used to predict the potential benefits of site-specific wildland fuel management programs. And of course, there's always limitations in any models, and that's true for the, our wildfire simulation models, especially under extreme fire. So there's two very different approaches and very few studies really try and bridge the two literatures very well. I like to pick on the people on the left because I'm on the right, but they may pick on us too. So, and the power, of course, I think in the future, in the next few years, is a better integration of these two science or let's investigative pathways. So I've been interested a lot in this cross-boundary wildfire problem, and it happened when, or my interest started when I was on the cohesive strategy science team. And so we see these fires start on large wildlands, national forests in this example, travel through checkerboard ownership or fragmented different ownerships of federal, state, private, industrial lands, eventually hit some kind of urban interface or developed area, typically starting as low density settlements that increase in density till it gets into the community. And the question that I mostly work on is, how do fires get from the left side to the right side? But there's a huge, science associated with what happens when it gets into that yellow area, spreads through very heterogeneous fuels and goes from a wildland fire to structure fires, and that's something that other people study, and we don't. We focus mostly on the left side of this problem. So fire exchange is not always one way. This is the Blue Creek fire near Walla Walla, Washington. Started in a wheat harvest operation, not by that combine, but one like it, and burned very rapidly up the wheat stubble. Wheat burns very fast and hot, especially before it's harvested, and burned onto the Umatilla National Forest and almost burned up the Mill Creek watershed that supplies all the water to the city of Walla Walla, which would have been catastrophic for the city because they would have had to put in a major re-engineered water treatment plant. So using wildfire simulation, one fire shown in the upper left, and if you repeat many fires under historic weather and yard up all the results and keep track of the ignition points and where the fires burned, you can and overlay that with ownerships, you can start to understand where fires start and where they go. So in the lower right is what we call a wildfire transmission network. And so each circle is a node in the network, and the size of the circle is how much fire activity is coming in and out of that ownership. And then the width of the arrows are how much fire is being sent from one owner or land tenure, land type to another. So in this one, you can see interchange FSM and FSP are managed versus protected Forest Service lands. So we can see, for instance, the interchange between what's designated as manageable and with active management versus wilderness areas and protected roadless areas, et cetera. So in this one, you can see a community node, and it's receiving fire from several different ownerships in this experiment. This actually is from the state of Colorado. We've done these networks for every state and for the entire Western US. You can decompose the community node and look at it in a bar chart. So here are the top, I think, 50 communities in terms of total expected structure exposure from fires. And so I use the term structure exposure, and what that means is a fire encircled or burned over that structure. We don't predict loss. That's a structural ignition problem. We just predict exposure, which is the juxtaposition of a disturbance in relation to something that you value, in this case, a structure and a fire. So here are the top 50s, and the colors of the bars show where the fire came from. So the orange is community, and that shows the exposure that's coming from within the a community, either that one or another one. The light green is Forest Service land, and then the brown is other private outside the community. And then this is the same graph shown as a percentage of the total. You can scan down this and see where the Forest Service, is a contributor of fire to this community versus all of the other different major land ownerships. So it's a first stab on, understanding through what ownerships fire arrives at communities. And we've done this for every community in the West as well. So scaling up to the west, when we mapped this out and filtered it to just sort of the hot spots, we came up with these, we didn't know what to call them, we called them blobs. And there are relatively few blobs that account for the bulk of the exposure. And so we thought, well, this would be a great prioritization framework or tool or map, and it's in the shared stewardship report. But we found that most of the exposure, 80%, was concentrated in the top, or I'm sorry, 80% of the exposure was in 20% of the communities. And so the exposure is highly concentrated in certain areas rather than diffusely spread throughout the West. But we started numbering these and trying to break them apart and trying to turn them into some kind of organized planning container that then we could individually prioritize and use in our scenario planning models that we'll talk about in a minute. And it didn't work well for a lot of reasons, but one of these blobs here, a small part, can contribute fire to many different communities. There's not a one-to-one relationship between communities and land that exposes communities. One piece of parcel, on a national forest can expose 5 different communities. That was one complicating factor. And there were others just based on the irregularity of it. And it didn't conform to how we plan for other natural resources, for instance, managing them, for instance, watersheds or hydrologists use watersheds, and flood risk scientists use, flood districts and flood plains. And it was just a little bit chaotic. So we came up with this idea of a regular lattice of firesheds. And so the boundaries of the firesheds and expanded to all lands, the boundaries of the firesheds are drawn where along gradients of where there is more or less risk transmission. So it's essentially a container that encapsulates areas of high fire transmission to communities. I want to note that this map is not, as noted in red, this is not a risk map. This is a source of risk map, which is entirely different. There may be very low risk inside these blobs. It's showing where fires come from that affect developed areas. So when that is encapsulated into these firesheds, you're identifying lands that have high exposure. And from a community standpoint, which I'm not really addressing, the wealth of different community hardening programs and firewise and fire adapted communities. And that's what, on the community side, on the right side of my simulation, we're trying to address the left side. How do we invest in active forest management and other methods to stop fires from getting to the community in the first place? So we found that the top 5% of the firesheds, each of these firesheds are about 200,000 acres. They were built with a process called image segmentation, which is a widely used remote sensing technique. And the top 5% accounted for 70% of the exposure. So again, very concentrated. So we had a regular system, and this was an experiment, and we floated it out, and it seems to help people organize and prioritize for investments, although it's still a bit of an experiment. So now our firesheds are all lands, and this shows the percent of Forest Service ownership in each fireshed. And we built a nested planning framework, just like the hydrologists use the hydrologic unit code system to, there are 3, 4, 5s, there's catchments and subwatersheds and watersheds and subbasins and basins, et cetera. We created a hierarchical framework as well. It started down with the stand, which is sort of a treatment unit, and we more or less arbitrarily define that at 250 acres, although you could rebuild this at any, stand scale you want. But and then project areas, and typically we do projects at 25 to 50,000 acres. So we nested in projects, and then firesheds, and then what we called a fireshed complex, which was 1 to 10 firesheds. And then the community fire sheds, which is a confusing aspect of this work because we used to talk about community fire sheds as the area that exposes one community to fire, which we've kind of abandoned now, sits in the middle. So here's an example fireshed map with the exposure rendered in the backdrop. So the dark areas are the fireshed boundaries, and then the smaller polygons are the planning areas within. So there's 5 to 8 or so planning areas inside each of these. And we'll later show you the reasoning for creating the nested framework. So from there, we started exploring, are there fireshed archetypes, for instance? How could we find higher level organization of this whole problem, community exposure? And so we worked on classifying each fireshed based on the fire regime. Is it fire adapted or not? The management capacity, are we allowed to manage in there? The amount of community exposure, the forest type, conifer, hardwood, scrub, oak, grass, rangeland, the expected fire intensity, the expected fire probability, and then economic aspects of treating it. And this is just sort of a dry lab exercise map where we created these archetypes and plotted them. And there's a lot of refinements that have to be done, but this is something we intend to pursue. There's way too many green ones, which are open canopy grass, shrub fuels, non-WUI, and we probably could break those apart a little bit more. So we had all the firesheds, and we wanted to use them to understand a lot of things, including, what's the trajectory, what's happening in the past, where are we going in these firesheds in terms of the future, and what's the present outlook. So in other words, you just can't walk in and start prioritizing if you don't have some context for the fireshed, just like the putting it into an archetype. So we built this fireshed registry, and John Phipps was instrumental in this. He was one of the main instigators that led us to do it. And we integrated in an ArcGIS portal information on who owns the fireshed, all the past treatments and past wildfire in recent history. And then we loaded the current outlook, which are risk and exposure maps. I consider the current outlook as the near-term predicted future by risk maps. And then we loaded in what we could find in terms of facts and data, which is Forest Service data or activities database. And then we built a provision to load in our scenario model outputs as well. So there's 2 futures. One is the Forest Service future, or future by any other lands. We have all lands in here. If we have plans and can find them, we were loading them in. But then our scenario planning model, again, which I'll show you in a minute, projects where we could be treating or should be treating based on a set of assumptions. We call it kind of a living atlas. It's an experiment, but it's the first one I know of that just isn't throwing massive amounts of data at you without some logic or reason behind it. So in other words, past, present, future for it. So I have a couple screenshots where you can zoom in this interactive portal to any fireshed and in any great detail and put down a fire history and a treatment history. And it's all shown on the map as well as numerically. We also experimented with, well, why don't we throw down some of our extreme simulated fire perimeters that are generated from the FSIM program, the Missoula Fire Lab. And so for each fireshed, we put the top 10 simulated fires that are predicted under essentially current conditions on it, so people can see plausible fire events, what they look like. So here are this. I'm sorry, but this is we zoomed into Sisters, Oregon for this example, and so you can see what given what's burned, what's been treated already to the best of our ability in terms of data vintages, what kind of fire events might we see? How big are they? So this lists the reference number of the fire, how big. So out of 10,000 fire seasons that are simulated in FSIM, this shows the the top 10. So there's a 250,000 acre fire, 100,000, 222,000, all shown. And you can, click these on and off and look at them. And we have the Microsoft building footprint data in here as well. So you can look at individual buildings, you can look at your house or structures and examine plausible future fire scenarios for the area. In contrast to a risk map, which shows a long-term average prediction as some expectation over thousands and thousands of fire seasons or fire simulations, this shows the actual events. And then in terms of the future, we tapped into facts, so you can look at, well, what's shown in 5-year action plans. And unfortunately, that data is pretty sparse. Some forests and regions put, their 5-year action plans fully loaded in there, and others don't. So it's a partial picture, but it's a vision of what we could be doing. And then on the right, this is where we ran a scenario with our scenario planning model again, which I'll show in a minute, where it suggested to treat under some certain priorities that we gave it. So again, we're looking at the future, there's two different futures or more. So we built this, and it got used for FY21 Forest Service investment prioritization in a couple different ways. It never determined an investment, but it likely either confirmed or helped make decisions. I think it's a safe way to say it. We're not revolutionizing, the prioritization process, but it was added information that was brought into several venues. One is this National Investment Strategy for Reducing Risk that is headed up by our deputy chiefs. The FY21 hazardous fuels allocation used some information from this. We use it to respond to Executive Order 13855. We are using it to develop shared stewardship performance metrics. So in other words, it's an accounting framework or a performance framework. And it was used to some extent in the Joint Chiefs Restoration Partnership projects, prioritizing those. So it was an experiment, really, in the agency. We've also used Firesheds and some other planning venues that are in progress, but in the end, it seemed like by organizing and creating a containerized system for risk to developed areas, just like hydrologists created the watershed condition framework and other spatial planning, both disaster and natural resource management have created their own nested spatial constructs. This one that was targeting this wildfire risk to communities or developed areas seemed to have some useful function. So these are the top 10 firesheds that map. So we ended up creating an investment portal. Our fireshed registry was too complex and still under development, so we made a light version that just had each of the firesheds, and you could pan and zoom and then look at the planning areas in the firesheds and query it and get various kinds of information on it. We made that accessible to the agency. And when we did this investment experiment, exposure face value is one thing, but what you can do about it is a totally different thing in terms of investments. And so, for instance, we removed recent wildfires in treated areas best we could. We removed protected areas, and we removed non-conifer forest land from consideration, treating this as an exercise in investing in an active forest management. And so total predicted exposure was estimated for each fireshed, and then we ranked the top 10 in each region, and again, the results were in a portal and still are. But we did some other experiments. These are the priority firesheds by states in the Western US. So these are the top 5 firesheds. We're looking a lot at Oregon right now, where we were close, but not close enough really to the fires that burned in the Northwest Cascades, Northern Cascades, Oregon Cascades. So, but some of the other areas are familiar to everyone. So, okay, so prior to the Fireshed work, we started this scenario planning project, and we had different spatial containers to use for it. And the example I just showed, we consider as a relatively simple investment scenario. But we can expand the scope with scenario planning to examine trade-offs and outcomes at multiple scales that the agency allocates investments, and also for co-prioritization as part of shared stewardship. I'm going to pivot a little bit here. So the Fireshed is this giant data warehouse that is intended to be a bit of a living atlas, but we can extract data from it and run scenarios. But not everybody is just interested in fire, obviously, and there's a lot of other resource management objectives. And so our scenario planning system was built as an all-encompassing system that could integrate different assessments to explore lots of different trade-offs other than just prioritizing community risk. It predated the Firesheds by quite a bit. So, and again, I want to back up just a little bit. So what is scenario planning? And probably a fair number of people have heard about this. We've given a lot of talks on it and have some science products as well. But scenario planning is a systematic method for thinking creatively about possible and complex uncertain futures. And it seems very appropriate for us to be interested in this right now. And so the central idea is to consider a variety of possible futures that include uncertainties in the system rather than focus on the accurate prediction of a single outcome. Many examples from business, government, conservation, restoration planning. And the studies have shown that entities, agencies, individuals that consider a wider range of scenarios as part of some decision-making process tend in the end to make a better decision. And this paper by Gary Peterson is a great introduction to scenario planning, talks about using it in a conservation context, but the parallels are obvious. So we built this, we call it SIP, Scenario Investment Planning Platform. It's sponsored by 3 deputy chiefs for National Forest Systems, State, Private, and Research and Development. And we've been working on this, well, I hate to tell you how long I've really been working on this, but in some way it's been a very long time to try and put all the pieces together. But the idea is to simulate the Forest Service, our land management activities. And so we take assessments, of which there are no shortage, and we take targets and budgets that come from Congress. And then we take the sort of allocation problem in the Forest Service, starting at headquarters, moving to regions, and moving to national forests, and using either historical or hypothetical allocation systems. And we take forest plans, local economics, fire management goals, and we simulate treatments. And we can simulate any treatment that anybody can come up with. But it's site-specific, it's high resolution, as high a resolution as people have data for. And then we run that out, over time, short periods of time in this particular system, and look at priority planning areas, trade-offs, and outcomes. And so for national forest, we can do 1,000 scenarios in 20 seconds. And shift priorities between, forest health, resiliency, forest deposits, terrestrial conditions, harvest targets, any quantitative sort of assessment information that people have, and then generate trade-offs with production frontiers to understand what kind of trade-offs we're making with decisions, and then predict short-term outcomes typical of say a 5-year action plan or 5 or 10-year action plan to look at the efficiencies. And we've completed probably a dozen case studies with this and continue to find it useful in our partnering up with NGOs and TNC and other people outside the Forest Service. So here's a simple scenario, back to Firesheds now, where we look a little bit more closely at prioritizing firesheds by region. So we're treating 80% of the exposure in each planning area. And what that means is we're treating 80% of the total exposure by area in that fireshed. The actual amount of area varies widely among the firesheds that we treat. We're filtering the lands for active areas that we can do active forest management, and we simulate implementing the treatments, and we spin this up and we go, let's start treating. How much exposure can we treat? Exposure to communities. And so as expected, it varies widely by region, but when you put these filters down, region 3 is the most efficient in terms of mitigating wildfire risk to communities from national forests with active forest management, region 5, and et cetera, but some very large differences among regions. Some having to do with area, some having to do with exposure. You can look at efficiencies and turn this problem inside out with this model. This is by state, so California, of course, pops up, Arizona, California, New Mexico, Oregon, but in all cases, you can see these asymptotes, meaning that, if we're even close to being right, most of the problem is highly focused on relatively small land areas. And other problems, like some of our ecological departure problems and overstocking problems and forest health issues, are spread over wide areas. And when you run this through the model, the relationships look either more linear or much shallower in terms of the response per area treated. So we're dealing with a problem that's highly focused and it's not like our 80 million acre restoration backlog on the national forest. It's a different kind of problem. By state, like I showed you, and this is by ownership for the Western US, showing that Forest Service and private lands lead the pack in terms of exposure to communities, tribal, and BLM down the bottom. So again, pretty nonlinear response. Most of the problem is a relatively small land base. Now I want to show you and sort of start closing here with the scenario planning at the national forest scale. So it's not just all about fire, and it's not just all about communities. And so we've done things in a number of national forests, and I think they're becoming very useful. But this case study is the Umatilla, and they have 40 some odd planning areas, a diversity of forest conditions, disturbance history, multiple restoration challenges. And they asked if we could prioritize their forest and fuel management for a 5-year action plan. And they had detailed stand prescriptions. We have inventory data for every acre, basically, with some of these new imputation techniques. And they asked for, an economic feasibility to examine, economic analysis to examine financial feasibility. And, there's this famous quote that the greatest challenge with restoration is paying for it. And it's becoming more and more apparent. And so we're paying a lot of attention to streamlining and mainstreaming simple economic analyses to look at the financial leverage of different kinds of treatments. And in a nutshell, if each of these bars is a planning area, and we work with the fuel planners and silviculturists and worked out filters for what was needed, where it was needed, stand types in terms of both the the forest vegetation and the fuels treatments. And so this is for each planning area, the restoration activities that are needed. So this is like running through the scenario planning model, but just with a filter to bin up the land base. And so each planning area has its own profile in terms of commercial thin, non-commercial, broadcast burn, pile and burn, whatever the treatments are. And, maybe this has been done a long time ago, but, I rarely see this kind of analysis for a forest or a region or anywhere else where they're asking, we see the 80 million acre backlog. Well, backlog of what? Is it commercial harvest or prescribed fire or broadcast burning or what? So with the economics, then we can cost out what the activities would cost in each planning area. And then we bucked the logs and sent them to the mill and sold them, but simulated that process so we could look at net revenue. And so all three of these can come into play as you, for instance, wanted to prioritize planning areas, and all kinds of financial substitution games or scenarios can be built off it. So that's what we're doing at the finer scale at the National Forest. Now, we ran a bunch of different scenarios using resiliency metrics and forest health, ecological departure, et cetera, and looked at trade-offs for those, and those are in some science products if anybody is interested in that. And this is for the 4 Blue Mountain National Forests. This is a scenario planning run where we did try these different objectives for prioritizing the planning areas. So here we're spinning up. Today we start, treating by planning area. We treat one planning area at a time, and we prioritize based on forest departure or insect risk or revenue or structure exposure from national forests or thinning volume or wildfire hazard. And the financial implications of the different prioritization schemes are extreme. If you prioritized harvest volume, you'd break even after treating about 1.2 million acres. If you prioritize ecological departure, it would cost you $400 million. So we have these assessments sitting on the table, many assessments, and this is a tool to tell us which ones we can, in a way, afford to use, or what kind of trade-offs we're going to have to make to use one versus the other. So, summary and conclusions. We created an all-land spatial planning framework and portal to address wildfire risk to developed areas. Work was originally motivated by the Shared Stewardship Initiative, although applications exist in many other contexts. For cross-boundary planning. Firesheds and a scenario planning platform can be used to integrate a wide range of assessments to examine investment trade-offs and outcomes of multiple scales. And based on early testing, the firesheds appear to be a useful prioritization and planning sort of construct at multiple scales, as does scenario planning. So with that, I will stop and we can open it up for questions. And
thanks, Alan. I'm going to let Margie, she's been keeping track of the questions. She'll direct those to you, and I'll keep an eye on the Q&A box. You all set, Margie?
Yep. Can you hear me?
Yep.
Great. So we have a lot of really great questions. Hopefully we can get to most of these. Let's see, where should we start? Does the fireshed archetype, such as fire regime, consider fire departure as a metric?
It could. The archetypes that we've done so far were just a quick and dirty experiment. But I mean, it could. You could put in the fire deficit. We did have fire regime in there, but not the departure. I guess the departure you could also call the deficit. But yes, it could.
Okay. Is the Fireshed registry dashboard available for anyone to access?
No.
Okay.
Is it going to be?
Is it going to be?
If people email us, we'll get them access.
Okay, fair enough.
Careful what you look for.
Can this tool be used in conjunction with pods, potential operational delineations, planning? And are these tools being used together on a forest?
Yeah, well, we are using, yes, it can. So pods is one treatment strategy where you're just pinpointing treatments. So, you can wire those in. But we're combining those with other kinds of treatments like forest health and economic considerations and looking at trade-offs. So the Washington DNR is using scenario planning, and the pods are in there, but so are other objectives at the same time. And what was the second part? or people using it on national
Yeah.
forests. Yeah, we are in the Umatilla and on the Stanislaus, and there could be others too, since we give people the programs. But I mean, that's just one spatial treatment configuration. We can do millions of other spatial treatment configurations if you have a rule set.
Okay. Another question, is this scenario planning approach akin to how statisticians would use Monte Carlo simulations in decades past?
Not really. We have two veins of research in scenario planning, and I didn't have time to talk about the other. This is highly deterministic. We use weighted objectives, and we pick stands to treat based on predicted outcomes. So there's no Monte Carlo business involved. In our longer term, although you can add on Monte Carlo type analyses by dropping down fires, predicted fires pseudo-randomly, and looking to see if you treat in the right places. We also have a long-term forest landscape modeling system that has essentially Monte Carlo fires that come in.
All right. Another question. I wonder if this framework could be used in bear mode, where if an actual fire burns near in a high priority area, we could, as the fire season winds down and risk to communities decreases, manage the tail end of a wildfire to mitigate not only current risk, but future risk by strategically firing in a way that connects that current fire footprint to areas of high risk that are nearby.
Yeah, I mean, we're using in that context for prescribed fire. We're optimizing prescribed fire blocks in the Umatilla and potentially elsewhere using those types of considerations. The model can solve, which we call forces, can solve a lot of different spatial planning problems like that. So without knowing the particulars, more particulars, you know, I can just say probably yes.
Okay, next. The fire sheds look like they are an arbitrary size and shape, e.g. blocky. Did the team include things like topography, actual stand boundaries, vegetation types, or other factors that influence fire behavior and spread to help refine these boundaries?
Well, the boundaries are based on fire spread because we use fire simulation outputs to create the boundaries. So they encompass fuels, weather, topography, and anything else that are predicted to determine fire spread to communities, specifically to communities. So it's not fire itself. The fire has to have a behavior that impacts communities. That's what determined how the boundaries were drawn.
And will this be expanded to Alaska?
It is. Because someone wanted it from Alaska, so we did it. We just don't have it. It's not in the portal yet, but it will be shortly.
And does your treatment, in quotes, result in the same risk reduction across forest types? A lot of California risk appears to be in chaparral, which responds very differently than forests to management.
Okay, so the scenario planning model can model any kind of treatment that you want to put in it and any assumptions about what it does to fire behavior. It's a giant spatial calculator. So if you simulated a bunch of chaparral treatments and where they went and did them, then it would, you know, make a prediction or use your predictions of what it did. You can use the system to, you know, prioritize anything, but the user has to put in, you know, what you're assuming you do and what you get for it. In our case, we, based on direction, we only considered prioritizing conifer forest vegetation types. And so what happened is a lot of the Southern California dropped out the prioritization. Now it's a scenario, and a scenario is just that, a scenario. When we put it in, this Southern California firesheds pop out a lot more as the top investment priorities. If you put that filter in, it changes it completely. And I don't have the answer whether it should be in there or not. It's different experiments.
Okay. And just so you know, there are a lot of thank yous in here, up and down. Everybody's really, really enjoying this. Has any climate change data been included in your scenarios? What about structures as fuel sources?
No, that's a real limitation, and we just don't have the bandwidth to take that on. We're sort of looking at short range planning problems. We do have a research portfolio using forest landscape simulation models where we are looking at climate change, but not in this system. It's a lot more complicated, obviously.
Yeah. Let's see, boy, there's so many great ones in here. Can you contrast these fireshed polygons from the concept of pods, also coming from RMRS? Are the boundaries of firesheds in this framework identifiable features on the ground that can be used in fire management actions?
They're not intended to be used in fire management actions. So they're intended to be used. It's for strategic budget allocation over, whatever, 166 million acres. Now, the scenario planning model can put treatments based on any logic anywhere. So, and allocate them in conjunction with weighted objectives from any other assessment and all combinations in seconds. So, pods are one scenario or a piece of one scenario, and a program can put them anywhere that they're directed with mathematical formulas or whatever you have.
Does this integrate with wildfirerisk.org?
I don't know what the word integrates mean. If you have any quantitative okay, in terms of the fireshed framework, wildfirerisk.org defines, to my knowledge, risk to communities. We're mapping the source of risk to communities and whether you can treat it. Two different things. Remember the fire simulation, there's a left side and a right side. We're working on the left side. We don't have maps and we're not considering, we gave up using communities as a framework. We're respecting all of the great work that's being done at the community level. The agency's investment problem is how to treat our lands to stop fires from getting to the communities in the first place. So the community work is important, but the purpose of this is to treat the source. So, and one of our fireshed polygons can impact 50 communities. And so the communities is really an inefficient way to attack this problem at scale.
Mm-hmm. Can you talk about the target audience? Who do you envision using this tool set?
Well, again, I sort of showed two things. The fireshed registry has been used by people in the Washington office to make allocations, investment allocations, and also sent that down to the regions for them to look at. So the intent is, say, Washington office down to regions, and from regions down to forests is where that fireshed registry framework probably doesn't work that well anymore because of local knowledge and other things. The scenario planning system that hooks to the fireshed registry but can take data from anywhere, we've used that for the state, New Mexico State Forest Action Plan. We're using it on different national forests. and we've used it within our research group to do national scenarios looking at a lot of different investment trade-offs. There's interest from the California Forest Observatory and various other people, Region 8. So it's really kind of a catch-all. I think anyone who has a prioritization problem at any scale could potentially use it.
Is the Fireshed registry available to the public?
No. But the Fireshed layer is, and we've given it out, and the Fireshed investment portal is available to anyone in the agency. We haven't made it available to the public, but we can if people want it. I mean, it's an experiment, and we can, unless I get 1,000 emails tomorrow, we can give people access.
And at what resolution are treatment costs estimated? Are they constant across firesheds?
No. So again, we have done work at multiple scales, and at the forest scale, work that I showed was stand level treatment costs. So it's based on tree size, density, slope, all the standard kind of variables that are used in costing out what treating a stand would be, plus transportation haul costs. So every stand is different in that context. The national work that we've done, we're trying to actually come up with costs and revenues for every one of our 250-acre stands, which we haven't done yet. But we have done some scenarios where the costs were averaged by national forests using data from facts. So we retroactively have found the area weighted, dollar weighted treatment costs for HF activities for every national forest and use those.
Let's see, this is in reference to slide 29. You may just know it. What land base does the last line graph on slide 29 represent?
This is my slide 29. So which is the last line?
Oh, I don't know. we can move to another.
Read it again. I'll try it and take another shot.
What land base does the last line graph represent?
Oh, I'm sorry. Okay, in the presentation. Okay, that's 6 million acres for Blue Mountain National Forest.
Okay.
And it's in a publication.
Let's see. Here's a nice long one, so I'll read it slowly. Scenario planning used in other contexts, e.g. climate change adaptation, often involves presenting qualitative narratives of different future scenarios to practitioners and communities and asking them how they might respond to these scenarios. These approaches can be useful for incorporating local knowledge and eliciting creative responses to change. Are there any opportunities to integrate your scenario planning approach and firesheds with some sort of qualitative narrative-based scenario planning effort?
That's one of our goals, and we're working again with a group in California. We're building a web-based version of our scenario model, so we can do participatory planning in that context. And we're going to roll that out in California as part of one of the several sort of prioritization efforts that they have going on down there. It's linked to the California Forest Observatory. So, and we've experimented with that in the past in some of our other modeling work, and I can't say it's been highly successful. It's a difficult problem. That's one of the goals for sure, to do real scenario planning.
Okay, and it looks like we have maybe one more question, time for one more. Expand a bit about scenario planning with multiple partners and how it can play out as a collaborative planning tool. Understand how it can be useful within one agency, but how might it play out further within a landscape with many partners?
Well, you know, we've presented scenario outputs at some collaborative meetings, and we don't have a lot of experience with that. I'll confess to that. And we have gone to some collaborative venues, and sometimes you know the analytics gets kind of heavy for that that venue. But we've gone to some and explained trade-offs, and so the value I think of it is in showing trade-offs from different priorities. That you know you can't have everything, and restoration you know costs money. And so that's one of the major advantages or possibilities in the future is to better illuminate trade-offs and choices we make about you know where we go and what we do at those places in terms of land management activities. And there's a pretty good literature on that too, in other planning areas.
So, Alan, how do you feel about going another 15 minutes with questions?
Sure. Yeah, I'm okay.
Okay, we'll keep going. Is the cost of treatment type and net revenue analysis publicly available?
Sure. It's it's in a paper, one of them, and in the appendix, and then this latest study. You know, we can make that available too. Now that's for the Blue Mountains, but it's not that hard to get to do what we did on the Umatilla in terms of building these restoration profiles. I don't find it particularly hard. You do have to run scans through FBS and run the econ extension to buck the logs, and so you can value them because you know logs are what get bought, and then the logging costs and the haul costs, that's relatively easy to do. So I don't see why any national forest can't do what we did on the Umatilla, and it certainly would clear the smoke on you know how much it's going to cost to complete restoration goals outlined in forest plans.
Okay, here's kind of a long one again, but a great one. The question of how to anticipate fire in the Western Cascades seems like a question of how to prioritize investment in low probability, high consequence events. In other words, the fireshed analysis you showed maximizes for the highest probability events, but 2020 makes it clear that we need to plan for communities across a wider array of probabilities. How might you propose we expand our thinking to account for low probability and high consequence?
Yeah, I know who that question's from. Well, I took a slide out that I had in here, and it's my wildfire risk map for the Western US, and every national forest is just painted red. And I showed that to our ELT 2 years ago. It's kind of a joke, but I'm wondering how much of a joke it is. So we're we're looking more at extreme events in the simulation record. And in Vox magazine, if you Google Vox wildfire, you'll see the result of that. So we found the worst wildfire in the simulation record from Mark Finney's simulations. And it burned 1.5 million acres and I think 80,000 buildings. It was down in LA, of course. And so that our thinking is towards trying to mine extreme events out of the simulation record to show that they can happen. In the case of the Western Oregon fires, you know, we didn't find them. And you know, I've mostly followed the blame game that it's poor forest management, which is, you know, completely wrong. And some people have analyzed that, you know, a large part of those fires burned through clear cuts that have been cut by private industry in the last 15 years. And, you know, might have been, you know, responsible for it. And so right now I'm just in the middle of trying to process, other than looking at extreme events, which we can't find, Probably turning to climate change informed wildfire simulation models with these types of events in them, or go to sort of a conditional simulation where we start creating events that we think might happen in terms of wind direction and wind speed and fuel moistures, and plop these down instead of using a fire simulation system that's based on historical weather, recombined historical weather, which is, not, it's not that that's a bad solution. It's just that we may need to start looking at plausible, well, that's the goal of our Fireshed registry when we put in the top 10 fires out of 10,000 FSIM fire seasons into the registry, so people could see the extreme events that were predicted, plausible and predicted, albeit with very low probability. So if you based your risk planning in each fireshed based on those top 10 fires, that would be a step towards an extreme event, low probability, high consequence event. So you can see in each fireshed, we also built mapped community profiles and are quantifying, it's a exercise in predicting paradise, we call it, but we're mapping and trying to predict plausible community disasters, and have found at least 400 communities in the Western US where there's a measurable probability that the entire community will be burned over just without even, the structure activity. So those are a couple of thoughts.
How does the funding compare between the two methodologies, and is there a difference in the funding source?
Try that again.
Let me try that again. My headphones just quit. Can you hear me, Katie?
Yes.
I can hear you pretty well.
I can hear you.
Okay. How does the funding compare between the two methodologies, and is there a difference in the funding source?
I'm not sure.
That's from the beginning. From the first few slides.
Okay, help me. Funding source.
It came from Patrick Shea. Patrick, if you want to throw another question in there that might help clarify that a little bit. And he follows up with the other question, Margie, I'll just say it. It says, does anyone evaluate the different methodologies for dealing with fire risk by the different types of ownership? Those came from the same gentleman, and we'll see if he is still on and wants to clarify.
The latter question, two answers. So we focused on just, how much risk comes from different ownerships, and not how they would deal with it in their respective forest and fire management systems. But in our long-term scenario modeling, we have programmed in agent-based modeling. We program in agent behavior that is derived from interviews from say land managers in private industry or BLM or whatever the different ownerships are. So we have those different types of we have owner-specific management regimes in these models, and can look at what the long-term effects of them are. In this short-term range scenario planning, we have not considered that different types of management on different ownerships.
Okay, and whoops, jumping all over the place. Hang on here. So can you share later sample published papers that show return on investment of forest treatments at reducing wildfire damage to lands, waters, communities, and businesses?
No, not financial.
Are those things that we want to add to send back to share with our registered participants today when we get the recording up? Is that something we can include, Alan?
Sure.
Okay.
And let's see, have any national forests used this information in their NFMA land management plans? Is this information relevant at that level of planning, or is application more relevant in the context of 5-year action plans?
The latter. Forest planning is a little bit different beast than what we're working on.
How was community defined? Was it a particular population size, number of homes, inclusive of unincorporated areas?
We took each census designated place name in the US, which is a point or can be a polygon. And then we attached all of the Silvis Wui polygon to it with a 45-minute drive time around it.
Oh.
And the average drive time is much less than that, but by extending it to 45 minutes, we were able to get 98% of the Silvis Wui attached to some town. So our community construct is artificial, but that's only used in the community prioritization part. The firesheds themselves are blind to communities. It doesn't matter what community it's in. And those delineations use the Microsoft building footprint data. So there's individual structures, but again, it's blind to communities. We've worked from the community. We used to work from the community side, and now we're working from the other side. But when we were working with communities, that's how we defined their geographic extent and population.
There is a direct correlation between future risk and post-fire treatment. Is anyone in Missoula or the Forest Service doing an analysis, sequence of repeated fire or success failure of post-fire treatments?
None that I don't know. It wouldn't surprise me if there were, but I don't know of any.
Let's see.
But there are plenty of reburn studies in literature. Susan Pritchard, for instance, B&W, and Sean Parks and other people have looked at reburning over time and the longevity of fuel treatments. And there's an extensive review by Kaylees and somebody else that look at the effectiveness of fuel treatments. That's not exactly that question, but it's related.
And do you include in the outlook variables like human behavior, frequency of gatherings, intensity of access by road, ATV, or other?
So the fire simulations in the Fireshed rely on the national FSIM outputs, and those do use ignition probability grids, to my knowledge, that are based, if they're ignition hotspots, then those should be reflected in the simulation. If you, excuse me, scaled, if you were to take on, say, a state of Oregon or a state level or national forest scale, you would, you might redo those simulations and create a more refined fire ignition grid to feed the model. And then it would reflect these ignition hotspots. And we do in our other scenario modeling as well. And I agree with the statement.
Given the operational and budget constraints of federal land management agencies, at which spatial scale do you envision the SIPP process being used?
Whatever scale people want. I think it's most useful at the national forest scale, but I think at national scale, if our leadership is interested in specific questions that we have not entertained in the past, about priorities and outcomes, that it has use at national scale and regional scale. And it's a giant experiment to see that. And there's social drivers here in terms of people's curiosity about, where all the money goes. And if that interest persists, then it's useful everything from national down to forest. I'd say even, you know, a ranger district could use it if it's a big ranger district with lots of choices. The more choices you have and the more sort of unknowns you have, the more useful scenario planning is.
And how did you assess potential treatment effectiveness in relation to preventing large fire spread?
So in this work, in this study, we don't at all. It's an assumption implicit in the work that when we go into our planning areas, we're treating 30 to 50% of the planning areas, depending on how much exposure is there is. We assume that we're eliminating the exposure. And of course we're not, but on a relative basis in terms of ranking planning areas and in terms of understanding sort of the nonlinear relationship, the treatment area and exposure, I don't think it matters that we don't quantify that. Now we have an add-on to our scenario planning model that will take the treated landscapes and execute command line plan map and simulate fires so we can quantify reduction in burn probability and spread rate and intensity, but we haven't found the need for that yet.
And one last question. Great work. What do you plan to do next?
Get on my bicycle and ride it. So we've got a lot of stuff going on. And we're working a lot on extreme fire work now, extreme event prediction, because I think that's where we need to go. I think our risk analytics might suffer from not being able to communicate. I'm not saying that they don't consider it. It's as a communication method that maybe we need to be looking more at extreme events. So we're working on that a lot, and we're working a lot on the long-term scenario planning with, you know, fire feedbacks and synergies between fire and traditional forest and fuel management as treatments over time.
Okay. Katie, shall we wrap it up? Thank you so much, Alan. That was all great.
Welcome.
Yeah.
Thanks for the attention and thank you for the questions.
Well, I just want to say thank you. I know I've seen some of the names on here twice today. We had a webinar early this morning, so thanks for sticking it out all day long. Those of you who've been on a couple of webinars today. Thanks very much for joining us today for Dr. Ager's presentation. There are a few questions still here, so if you'd like to ask them, I can forward them on to Alan Ager and perhaps he can answer those at a later time. I will say that a recording is ongoing, and as soon as we're done and I receive it back from Zoom, I'll edit it and put it on our YouTube channel on probably by next week. So watch for that. I'll send a note to everybody with that link who was in the registration list. So unless there's, what am I missing, Margie?
The only thing you were missing right then is my dog barking. So I think.
Oh, well, good, good. Thanks everybody. Really appreciate your time and attention today and for going a little bit longer than an hour. Hope you all have a good week.